Hey everybody, here with Chemistry Cat. Two men walk into a bar. The first orders some H2O. The second one says, "Sounds good. I'll have some H2O too." The second man died. The bartender took it to mean H2O2, which is peroxide, not water. So today we are going to be learning about single replacement reactions. And on page 293, you will find a table that looks just like this one. And this is called an activity series. And what they have done is they've listed under the metals here the most reactive, they call them active, metals. Lithium would be the most active or reactive. Then it would go to rubidium, potassium, calcium, on down to gold. So from the top down to the bottom, the element there is becoming less reactive. And they've also listed the halogens. The most reactive halogen would be fluorine. Then it would be chlorine, bromine, and iodine. And this table here is going to help you to determine if the single replacement reaction occurs and what kinds of products you are going to form. So here are your notes. I hope you've accessed them so that you can take those while we're going through them. The fourth reaction, single replacement, you have one element replacing another in a compound, and you'll have to refer to this table over here to see if that single element can in fact break up the compound and take the place of element it wants to kick out of that compound. So if we're looking at metals, say, that would be your single guy right here, A. A would like to kick out the metal that is attached to probably a non-metal. And here you would see that the A comes in, takes the place of B. B gets kicked out. B is the single guy. And now A has bonded with X. In this reaction right here, Y is representative of a halogen. This halogen would like to come in and take the place of the halogen, which is represented over here by X, and it would like to bond with B. So here X gets the boot, it's going to be the single guy now, and Y has taken its place and bonded with B. So you absolutely have to have this table in order to figure out, does the reaction occur? And how you're going to be able to tell that is if the single metal is higher, if it is above the metal that is bonded, then the reaction will take place and the metal lower down will get kicked out. You'll see what I mean in just a minute. If we're looking at the halogens, you want to look at the halogen that wants to do the bonding and see if it is above the one that is already bonded, and if it is, then the reaction will take place. So in this first example here, I can get rid of myself. Okay, aluminum would like to come in, and aluminum is a metal. Aluminum would like to kick out or replace the iron that is bonded with this oxygen over here. Now remember, with all of the reaction types except combustion, I have given you the coefficients on the reactant side. Okay, so we have to look for aluminum and we have to look for iron. Now take a look at this activity series. Here we find aluminum. Aluminum is the single guy, and is it strong enough to kick out the iron and replace it? Well, here's the iron down here. Yes, aluminum is strong enough to break the bond here and give iron the boot and take its place. So aluminum is going to come in and bond with your oxygen. So I have two aluminums and three oxygens, so I will write Al2O3. And I have to figure out, well, what's my other product? Well, iron has gotten the boot. I will write iron, which is Fe, and there's two of them. Where's the two going to go? Well, iron is not one of those Brinkelhoff twins. It is not diatomic, so we have to put the coefficient of 2 in front. Remember, both sides have to show equal numbers and type of atoms. 2 aluminum on the left, 2 on the right, 3 oxygen on the left, 3 on the right, and here's our 2 iron here and 2 iron here, so that equation is balanced. In our next example, calcium. Calcium is what? A metal or a halogen? It would be helpful if you had your periodic table handy. That way you could know for sure. So calcium is right here. Calcium would like to come in as a metal and kick out sodium. Sodium, where is that? It's right underneath. So calcium is more reactive than the sodium, and it can break the bond right here between the sodium and the chlorine. And calcium is going to come in and give sodium the boot. Sodium is going to break off, and I have 2 sodiums. Where's that 2 going to go? Got to go in front. It's not diatomic. My other compound, calcium comes in and takes its place where sodium once was. And calcium bonds with the chlorine. I only have 1 calcium, but I have 2 chlorines. 2 chlorines, and I'm going to put the 2 here. So both sides will be balanced. So give this next one a look. Now, magnesium. Magnesium is a metal, and it would like to come in and break this water. HOH can be written instead of H2O. You can write water as HOH. It would like to break it right here. Now, hydrogen is not listed in this activity series. I've typed it in right here. So it falls between lead and copper. So we have to find magnesium. Magnesium is right here. Now, magnesium is above the hydrogen. It is more reactive or active. So this reaction will proceed. Magnesium will come in and break the bond right here. Hydrogen is now going to be by itself. At least this hydrogen will be. The OH group, the hydroxide group, stays together. So I've got 2 hydrogens. Does the 2 go in front or behind? It's going to go behind because hydrogen is diatomic, and that's where you have to put a 2 afterward. So magnesium is going to come in here, take hydrogen's place, and bond with that hydroxide group. Now take a look at our hydroxide group over on the left-hand side. How many hydroxide groups are there? There's 2. Okay, the 2 applies to every element as a coefficient throughout this compound. So there's 2 hydroxides, and I want to keep that hydroxide together. I will put the 2 afterward. Now, if you're trying to figure this out, you have to kind of remember, well, magnesium has a positive 2 charge as an ion, and our hydroxide group has a negative 1 charge. So I'm going to need to have 2 hydroxide groups in order to create a compound that has a neutral charge overall. Okay, so if you remember back to chapter 7, equal but opposite charges. Okay, so our 2 negative hydroxide negative 1s add up to a negative 2, which balances with the positive 2 of the magnesium if you want to go back and review chapter 7 material. So take a look at our next example. You may want to pause the video and determine, does this reaction take place? Okay, so nickel would like to kick out the zinc. Here is nickel. Well, look at where zinc is. Nickel is beneath zinc. Nickel, being the single die, is not able to break this bond. So this reaction will not occur. So you write NR for no reaction. Okay, so nickel, the single die, has to be, it can replace anything beneath it, but nothing above it. So it could kick out a tin, a lead, a hydrogen, a copper, a silver, a platinum, a gold, but none of these elements above it. So this reaction doesn't occur. Take a look at our next example. In this example, we have bromine. Bromine is a halogen. Bromine is third down on the list of our halogens as reactivity goes. So bromine would like to come in and replace the thing that is like it. So does it want to kick out the potassium or does it want to kick out the chlorine? I hope you said chlorine. Okay, so bromine is beneath chlorine. Can this reaction occur? The answer is no, no reaction. And so that's what you would write, a big NR for no reaction. Bromine can only replace something that is beneath it. So it could only replace iodine. It cannot replace a fluorine or a chlorine. But a fluorine or a chlorine being above the bromine could replace bromine or iodine. Now take a look here. Bromine is going to try again. Bromine would like to come in and break this bond right here between the potassium and the iodine and take iodine's place. Can this reaction occur? Well, the answer is yes. Look at where bromine is. It's definitely above the iodine. So bromine is going to take iodine's place. Iodine gets the boot. Now, how many iodines do we have? We have two of them. So we write I2. If you remember Brinkelhoff twins, iodine is diatomic. Bromine is going to come in and take its place. Now, I have two potassiums and I have two bromines. The metal always gets written first. So I've got two potassium and I've got two bromines right here. And what should happen to that two and this two? It should be pulled out and put in front as a coefficient. Okay, there. So we have our reactions taking place here. You're going to get yourself a little bit of practice on the worksheet there, and anything that you get wrong, remember I highlight it and I unsubmit it and ask you to fix those highlighted areas. So give this a shot and good luck. Remember I do have office hours. Thanks for joining.